Good to see you, Ben.
You too, man. Talk to you later. Okay, I'll I'll just get going here. Hey, everybody. There's 29 of you there, so, since I've done talk online, so it's kind of nice to jump back in and see how things are going here. Let's see. I've always been interested in building stuff since I was a kid. I did an electrical trade out of school in Australia, hence the strange accent. And I did that for a while, mostly working as a subcontractor or a civilian, I guess, in the military in Australia, doing fiber optic cabling and stuff like that. Then I went traveling and did a lot of carpentry work in the UK, in England, and then bounced around the world for a long time and ended up in Canada, which is where I live in Vancouver. And I've got a little family here, and we build tiny houses mostly for people who have got health challenges and are trying to find a neutral space to call home that isn't affecting their health. So it's from conditions like fibromyalgia, chronic fatigue, multiple chemical sensitivities, electromagnetic sensitivities, and everything sort of around that. So that's our niche. This is like a little profile of the different work that I've done. So the top left was basically my job for the first early part of my life, running in cables and fiber optics and doing electrical work. Then I got into some commercial stuff. There's a picture of a Rocky Mountain chocolate factory that I was building a while ago. And then at some point, there's a photo of me there. Sorry, maybe a trigger warning for sensitive folk, but I had a toxic shock event, which was I was working on a job site, and they had a two-part chemically hardening chemical paint that we were putting on the floor, and my whole face just blew up. I was in the hospital for a little bit, and so I had this toxic shock event to that paint and VOCs, the volatile organic compounds that are in the paint. And I was on cortisone for a while, and I'd always had sort of sensitive skin, but this was a big one. And then from that point on, I kept being, well, my body just went into a shock every time that there was like brand new paints or chemical stuff around job sites, which is everywhere on new job sites. So that sort of moved me along a path of trying to find a healthy work environment. I went down to Earthship Biotecture in New Mexico and worked there for a while. I did natural building with cob and straw bale and these kind of materials. And then as my little family started and I had to be more stationary, I was asked to build a non-toxic tiny house. And then that sort of created this whole career that I'm in at the moment. And I've been doing tiny house building now for over 10 years. It's a picture of one that's down in Portland that we built a few years ago. Bryce from Living Big has a video of that one if you want to look for it. So what I'm going to talk about today is what's a healthy home, some thermal bridging stuff, and I might do a different screen share on that. I've got a SketchUp model where I can spin around my trailer and show you how I build them. Insulation, ventilation, electrical material choices, and I'll probably have some time at the end for some questions if anyone has any. So, what's a healthy home? I think everyone's looking for that magic bullet of answers, but it really is different for everybody. For some people, a healthy home is just not using new materials, as in like salvaging stuff from the restore or habitat. For them, that's where it's at. Everything's gone through its off-gassing cycle, and they're trying to also sort of help the environment by not participating as much with new materials of construction, which is accounts for an enormous amount of our carbon footprint on the earth. But the main one that I'm dealing with people is yeah, avoiding harmful ingredients. So low VOC. VOC is volatile organic compounds, like I said before, and most products now have that on there. So if you go to a paint store, it's going to say low VOC, um, which is the minimum that you should be looking for, in my opinion. Um, I'm definitely in this world a little more where I'm dealing with the canaries in the coal mine. Um, but a lot of these things are going to come back and bite us, and probably already are in a health sense. EMF is electromagnetic frequencies. So this is the the frequencies that are emitted from Wi-Fi routers or just electrical lines. And then the other one is good ventilation. And I'll go into these things a little more as we move along. Um, Existing allergies or sensitivities. Yeah. So some of my clients, actually, we have to go through a self-testing process. So if we're going to use a glue, or if we're going to use some caulking, or even just the lumber, um, either I cut up some of that material and send it to them in envelopes for them to sort of exist with, put under their pillow, to make sure that when they do get their home, there's not something that we didn't test for that's going to trigger them right away. Answers before it's delivered. Anyone who's opened any fridge knows exactly what that smell is like. Or if you just go into an IKEA store or a dollar store, then that smell is just that new plastic kind of smell. As much as we can get rid of that without kind of a job. Anyways, so this corruption, and the house is create an air gap. Let's say a freezing temperature, and because it's metal, the bridge is that the metal is going to run right through, and well, the temperature is going to run right through that metal and touching the underside of your subfloor of your plywood, and then it becomes wet, and then it can start dry rot, and then that can turn into mold, and it just becomes unstable. So I might come back and do a spin around the trailer frame later, just because I got a message there saying my internet was dodgy. So I might leave that for later and keep moving forward. Um, and then I can show you the detail of that subfloor attachment. Um, okay, the other one with thermal bridging is the steel stud versus wood. Um, I'm not sure how many steel stud builders there are out there anymore, but I'm guessing mostly in the southern states. In Canada, not so much because of that thermal bridging, as the cold temperature on the outside of the house is going to track through those steel studs to the inside. There is ways to avoid it by wrapping, putting an outsulation layer, and I'm trying to remember the name. Is instead of wrapping a house with straight up plywood on a steel stud construction, usually you're using like a half-inch layer of which is thermal break, which isn't bad, but it's not so good still in really cold temperatures. The other common thing that's used with steel stud is spray foam. It seems like most builders use spray foam, and I've got a little spiel on that as well, which is not as encouraging. We also don't put any plumbing on the exterior walls. It's just a huge no-go, and especially with tiny houses, even if they are being built in the southern states. I mean, it froze in Florida a few years ago. And if you've got plumbing on the outside of your house, then it will freeze. And freezing means that it's going to crack. Even if it's a tiny little crack, it can destroy your house. water destroys houses like crazy. And destroy maybe not structurally, but if you've got mold growing in the walls, uh, almost all my clients have some kind of a mold sensitivity that they're dealing with. Which brings us to the insulation bit. Um, that top one there, rock salt mineral wool, is pretty much our favorite. The reason is it's available, it's cost effective. Because it's an extruded mineral, like it's just made out of rocks, and this whole extrusion process, which you can look up on YouTube, which is pretty crazy. But they turn rocks into this fluffy bat that is quite stable, easy to deal with. It's itchy as hell, but it's fairly non-toxic compared to some of the others. Not the others that you see here; these are all great. Um, but in the general construction sense, there's very little fire retardant in it because it's just rocks. So that's why we go with rock wool. The other one is wool down the bottom, which is pretty popular. The thing that I've found with wool is when you're stapling it, you have to staple it up on your verticals, which means you're compressing it wherever those staples are, which means you're losing R value. So I don't mind using wool on horizontal surface like the ceiling or the floor, but on the walls it doesn't really work so well. So I'm not as comfortable using it. And then hemp bats have always been threatening to become popular. They're hard to find. Wood fiber is great for outsulation, which should be on the outside of your studs. Very non-toxic. Straw bale, maybe not for tiny houses. Okay, SIPS panels. I think there's other builders that are using these quite a lot. I know Minimalist in Quebec use them, and they build beautiful stuff. Really great for cold climates. As far as the non-toxic level, not as good. We've got just regular OSB strand board plywood there and a foam layer inside. But I know there's a lot of tiny house builders that use those. We do not. That middle picture, fiberglass, that's got the most amount of fire retardant in it. I'm sure those guys are going to be regretting not wearing masks installing that stuff. It works. The R value is slightly lower than rock wool, but it's definitely the cheapest option. Spray foam it seems to be really popular in tiny house world. And I've got a little spiel on that later as well. You could see this person's in a hazmat suit installing it, so it's definitely not suiting what I'm doing my builds as far as keeping things non-toxic. Reflectics are pretty great for people use them in vans and stuff like that. And then we've got expanded and extruded polystyrenes. Again, similar to the spray foam in their R value. I mean, the spray foam and these XPS CPS insulation are the most bang for your buck as far as R value, which is how warm it's going to keep you. And that's why the spray foam's being used a lot, I guess, as you get a bigger R value. And in a small space, maybe you don't want to have 2x6 walls. So that's that. Okay, spray foam. I'm not going to spend too much time on it. Scare everyone too much, but this is what, I mean, maybe the installation wasn't done so well, but this is what happens to spray foam after a few years. What happens is you've got a dead material, being the spray foam, getting sprayed into a cavity or inside your stud walls. And over the years, it gets more and more rigid. That's just the nature of spray foam. The studs do not get more rigid. They expand and contract each season. And the example of that is when you've got a door that becomes sticky in winter. It's just because the wood all around it and maybe the door itself has expanded just enough to get tight in the frame. So each side of each of those studs has a micro crack in summer when the studs have contracted and the moisture's left the building. And that creates this micro crack where the moisture can't be released because it's just a small crack. The other thing it does is it completely is not a vapor barrier anymore. Um, so you've got this situation where you say, okay, spray foam is a vapor barrier. After a few years, it is not a vapor barrier. So the worry there is the spray foam is breaking down, which is releasing chemicals. And then also you don't have a vapor barrier and you've got moisture in the walls on your studs, which can become old. So I really feel like the spray foam thing can show up as pretty unhealthy homes one day. That's why we do not use it. I have used it in trailer frame because we're going a dead material to another dead material, being the metal. But when you're putting it in with wood, which is dynamic, that's just not a practice that we agree with in regular construction industry. Um, just the companies that are making it themselves, we're not, don't like to support. So that's my little doom and gloom for the day. Okay, the other thing that we do is we use breathable vapor barriers, which is the picture there on the left. That's the brand that we use. It's called Intello. Um, it's available through 475.com, and that's a that's a high it's a high end building supplier, uh, building materials. The tape and the Intello, and on the exterior is called Mento, is the products that we're using. But we're mostly starting from inside out when it comes to our keeping the inside air quality great and making sure that we don't have moisture in our walls. On the right hand side here, you've got a plastic vapor barrier, which is called poly. It's a 5 mil poly generally, and there's no water that can get through that. Well, there's no vapor pressure that can get through that. So if there's any water vapor or on the inside of that vapor barrier, it's just going to drop to the bottom and sort of find itself behind your baseboards with nowhere to go. Um, there's it's not happening all the time, but if you're boiling water and you don't have your ventilation on or your hood fan, that moisture will make itself through the wall, get through the walls, through your drywall, through your wood, and hit that vapor barrier and just drop. And it's very hard for it to dry out. So that's why we're using breathable membranes, so that our walls are hygroscopic, as in the whole wall is able to breathe in and out, and the moisture has somewhere to go on both sides of that vapor barrier. So yeah, anyone who's done any renovations would have seen this kind of situation before. You pull off a baseboard and there's just black mold behind there. Mold's usually growing with a relative humidity of 60%. And so ideally, we're keeping the humidity in our homes below that. You can use that with a dehumidifier. Mini splits have a dehumidifier built in. But depending on where your climate is, we're up here in the Pacific Northwest, it's damp all the time. It's a rainforest. So it's something that we're taking particular care of. As far as getting rid of mold, clove oil works really well. It seems to actually dig in or migrate into the mold spores and kill them. Bleach makes it look like it's gone, but it's generally just killing the outside of like the surface or the superficial mold instead of like actually getting into that drywall and killing it. So if you have mold around, a little spray bottle of clove oil at like 20 to 1 or something like that to water works really well. Windows. Yeah, so again, with the thermal bridging here, if you've got aluminum windows, that cold temperature is going to get trapped inside and you're going to have to deal with the moisture. It's somewhere either halfway through your wall where you can't see it, or right on the inside. That little picture there is pretty common. I mean, that's a single glazed window, so you're going to see that a lot. Um, but but yeah, that's fairly typical. What we're using mostly is vinyl. Uh, it's the way that the window flange is on a vinyl new vinyl window is really easy to make airtight and have a good connection so that you don't have any transfer of air around your window. It also doesn't bridge moisture through vinyls. Vinyl, it's funny. I'm not sure if it holds an armor like wood, but it doesn't track that thermal bridge or that heat from outside to inside the same as aluminum does. Wood's just becoming more and more expensive. Wood windows are beautiful. They do require some maintenance. And that's you see them less and less, unfortunately, unless your thing is salvaging materials from the restore. I just added these two last night about skylights because we're still talking about window openings. I actually don't do them anymore. As great as they are, I've said it or if it's common in construction, but there's two kinds of skylights, one that doesn't leak and one that hasn't leaked yet or something like this. So I don't do them because one of my things with my roof is that I'm always using Prolock standing seam metal roofs, and them being compatible with skylights is really difficult to get the flashing detail correct. We're putting a big penetration in the number one area of the tiny house that wants to get waterproofed. So I have been talked into it a few times. The other thing is just the pitch of the roof. Never in a tiny house generally is not lending itself to skylights. I love a skylight, but I've been moving away from installing them. Just if they leak, then your house is done. And then the other one, just about our windows that I thought worth noting there is if you've got a loft, then try and have two operable windows in the loft. One that's got an egress size to it, so that if there's a fire, you can get out without having to run downstairs. But mostly it's about cross ventilation, because the loft can get stuffy. It's a really small place. They heat up a lot in summer, no matter how much insulation you put in the roof. And having those two windows in the loft, you can get a fan in there and the air's moving around nicely. Just check the time. Okay. Okay, propane. I don't know why I jumped to propane appliances, but that's what we're doing. That's what we're doing. I guess this is tying into our indoor air quality. If you've got a direct vent, and this is more common if we're building houses that meet sort of the what is it, Appendix Q of the International Tiny House Building Code. I believe direct venting propane appliances are in there. If they're not, there should be. So instead of drawing our fresh air from inside the house to burn propane, it's actually drawing the air from outside, and the propane appliance that's inside is sealed from the interior of the house. So it's its own breathing system. If you've got an open flame propane appliance in your house, which is, I mean, it's common for heating and this and that, then there can become a moisture issue. I believe it's 1.6 gallons of moisture that's created from every 1 gallon of propane that's burned. So that does create more moisture in the home that has to be dealt with. The direct vent propane appliances don't have that problem as much. The other one that we install on all of our tiny houses is this fancy little appliance here called Lunos. Again, it's from Germany. It's a heat recovery ventilator. And see if this, you know what, I'm not even going to go there for the video. It's basically the lungs of the building. And if you see the graphic there, there's an E2 in 2 of these rooms. These are regular size houses, but in a tiny house, we just need 1 set of fans. So it comes as 2. I'll install 1 high in the ceiling area and 1 low, and ideally at each end of the tiny house, but not in the bathroom. And one breathes in while the other one breathes out. And then every 70 seconds or so, the fans change direction. And you can see on the left-hand side graphic here, there's like a porcelain baffle. It's like a little radiator there. When the fan's breathing out, that's getting heated up by the air that's leaving the home. And then when the fan changes direction, that cool air coming from outside takes that heat that's been heated from the inside air and picks and heats up that outside air as it comes back in. It's not a heater, and it does work in the opposite direction as well if you're in a hot area and you're needing cooling. And what it means is that it's super efficient as far as uh, you're not just getting exhausting that air out of your home that you've spent money heating. It is leave that air is leaving the house, but it's being reheated as it comes back in because of that smart little porcelain baffle there. The other nice thing about these is they come with MERV 18 filters, or you can get MERV 18 filters for them. And what that means is that your air quality inside can be better than outside. So MERV 18 will filter out pesticides and smoke. So what it means is inside your tiny house has always got fresh air and potentially better air on the inside than the outside. So for me, these are a critical part of having a healthy home. You could have some, you could just use regular building materials and have your, regular VOC paints, carpets, whatever else. And if you have one of these systems in there, then at least your air is being replaced every few minutes on the inside of your home with fresh air from outside. So yeah, this one's pretty critical. It also drops moisture as far as the fan itself. It's a decentralized unit, so it's just a pipe going through the wall, and this mechanism's inside. And the pipe sloped slightly to the outside. So when you've got that heat exchange happening between cold and hot air on that porcelain baffle, the moisture can drop and it runs down the pipe to the outside. So it does act as a little bit of a dehumidifier, depending on the climate. The other thing we take particular caution with is the bathroom. And I mean, every bathroom just has to have an extractor fan anyways. Sometimes you'll see old houses that do not. I don't know if they're built before fans were invented, but yeah, you have to have it. The standard one that we use is a picture down the bottom there. It's a Panasonic. It's a really quiet. I think it's called a whisper quiet, whisper fan, whatever. The other nice thing about this one in particular is that it's got a really low profile. So if you are building regular loft out of 2x4s or 2x6s, then it's not one of these tall extractor fans that's taking up your entire ceiling space. That's just 3.5 inches deep. So it works nicely for us. It's a picture there of a shower dome, which are not common in the US or Canada, but in New Zealand, this is really common. And it's such a smart way to deal with the moisture coming out of your shower. Generally, you're always going to have that steam in the air, which the fan can get rid of. But having that shower dome just means that the bigger droplets of moisture are hitting that shower dome and then dropping down the inside of your shower and into where the moisture should be, which is down the drain. So we've sort of recreated that shower dome on this bathroom picture with the shower tub situation you see on the right hand picture there, which is we've created a slope. We've put the fan in that slope, and then the moisture droplets can run down the back of the shower and into the bathtub. It's not in the building code to put a bathroom fan inside a shower. For anyone that's going to be getting crazy about this image, what I do is in bathrooms you install a GFCI, which is a ground current fault interrupter. I'm sure everyone's seen them. It's the socket that's got the little button on it, so that if you put a fork in there, you don't blow your finger off. It just cuts out in 30 milliseconds or something like this. So what I do is I connect that fan to the GFCI in the bathroom so that it's safe to be inside a shower. I think the reason that it's outside of code is because someone decided to try and service the fan while there was water in the bathtub, and they probably hurt themselves. But you want to put the fan exactly where the moisture needs to be going from, which is right there. So that's the reason we put it in there, and that's how we keep it safe. The other thing in the bathroom is about just moisture on the walls generally. So it's fine to, if you've got good moisture control and the fan goes on when you're having a shower, then you should be able to deal with it. You've got a good vapor barrier. Let's say the rest of your walls are going to be plywood or tongue and groove. Tongue and groove's pretty popular, I guess, in tiny houses, or even drywall like a regular house. And then the inside of your wet area is going to be something like this, the Curdy board with tile. And I'd say this is the best solution to keep moisture from migrating into your walls. The nice thing about this Curdy board, and there are other brands as well, um, is that it's actually a foam layer. So it's, again, we've got this thermal bridge situation, and the slide before we've used metal there on the walls. There is potential for thermal bridge on that, whereas where you can find metal moisture on the back of that metal. So for us, we've got a separation of a ½ inch behind that metal there, so that the water can drop into the tub behind the flange or in front of the flange if there's any moisture. But if you're just doing a regular insulation, then the Curdy board and tile is great in the bathroom. And if you are using plywood or TNG, then I just suggest putting a good exterior grade, either stain or like a siding stain or something like that on it, so that it's really protecting itself from moisture in your bathroom. There's a little thing there at the bottom which might be hard to see, but that's generally how I'm doing the ceilings in my bathroom or in the lofts. It's called, it's just 1.5 inch by 6 inch truck deck. So it's a tongue and groove board. And what we do is we join it together with silicon. And so there's no moisture able to get from that lower room, the shower or the bathroom, up into your bedroom space. And there's no cavity for any additional moisture to exist, especially below your bed. You can see it makes the lighting a little tricky, and there's some challenges with it, but I like to do that so that we don't have any cavity for moisture to exist between the wettest room in the house and the underside of a mattress. Kitchen moisture control, I don't know if there's too much to say about this. The one on the left, the 600 CFM, is what we use. It's a nice low profile, and it just slips into the underside of an overhead cabinet. That one's about 250 bucks. The 270 CFM is about 100, and then that the 350 CFM one there's around the same, so 300 bucks. CFM is just how much air can be moved per minute, and we're always going for the highest amount. It can be loud, this 600 CFM one, but like I said, we're trying to keep the humidity in the tiny house to under 60% so that there's no chance of mold growing. And there's different settings on that 600. So if you've got it low, then it's going to sound more like the ones on the right. But when you're really boiling water for pasta or whatever, then you can just crank it up and you know that that moisture's gone. So again, moisture is the enemy in a tiny house. Okay, quickly on heating and cooling. The mini splits are pretty common in all of our tiny houses these days. I mean, it's hot and cold everywhere, so those work great. They do both. They don't do the best job of heating, but if you've got a well-insulated tiny house, they can work great. The nice thing that they do really as well is they do a little bit of dehumidifying. There's moisture that's created again just with the heating and cooling from that head unit, and there is a pipe that runs from that head unit to the outside that drops moisture. I think mostly during the summer, if I'm thinking right. We use these brands, they're from Montreal, called Senville. The reason we use them is because they're rated for -40 degrees. I don't know if that is in Fahrenheit, maybe 0, something like that. Again, just because we don't know where our tiny houses are going to be moving around on the continent or in the world. So we're trying to cover all the climate zones in our appliances and how we build them. Wood stoves are great. I don't know if I'd put one in my home. I mean, I love the idea of a fire in there, but the screen's like about as big as your cell phone, so it's not like you get that real fireplace effect. They are good for drying out the air, and they're good in sort of an emergency if you're somewhere where the power is going to go out potentially in winter or something. But they do take up quite a lot of space, and you have to feed them a lot because they're so small. That you can only put, tiny little pieces of wood in there and they're burnt up pretty quickly. So this is that's kind of that's my spiel on the fireplace. Uh, Electric floor heating we've been putting in quite a bit. We also have put in hydronic floor heating. It's quite a lot more expensive, mostly because of the appliance that's used to get that to get the water through. Um, but if you're using hydronics, then you can rely on propane for your. It's called a combi boiler. So there's two boilers in one. One's for your hot water, and the other one's for the floor heat. And those combi boilers are about 4,000, and another 4,000 or so to install because they can become quite complicated. And then if you've got power available and you're just after some heat, like a space heater, these NVs were popular for a while in Tiny House World. I'm not sure if they're still being used so much, but I've installed a few of them. They're basically the same thing as a baseboard heater, except they've got a little fan to move that heat around the space. Okay. Into the EMF component, which is for some people a really big deal. Some of my clients that I've chatted with can hear Wi-Fi. Uh, they've got constant headaches and they're having to like drive their car out of town into the country where there's just less cell phone signal or service or Wi-Fi or any of these things, just so they can have a good night's sleep and find a calm space. So I've done some designs to separate the bedroom areas specifically from Wi-Fi, and you can do that using like a mesh. It's like an aluminum mesh that you can put in the walls and completely isolate your bedroom from any Wi-Fi. So if you go in there with a cell phone, then it will not work. Um, that's one solution. It's a very expensive one, and most people aren't that sensitive. The easier way to do it is to keep electrics away from your bed area. And I've got a graphic of that I think coming up. Turn the phone off and turn the router off. Turning your Wi-Fi router off is huge, especially now that we're into 5G. You can see the kind of radiation that's coming from a Wi-Fi router in a regular house. So you want to stay at least 3 feet. No, I think they say more than that. Maybe it's 3 feet on the Wi-Fi manual. Um, but 10 feet away from your bedroom at least to not get a strong signal pushed through. Pardon me. There's these Wi-Fi meters that you can buy if you've got to worry about that. You do have to get a good one. The ones on your phone show up something, but then you've also got a cell phone signal, like sort of making it less accurate. There's a regular power there in the middle photo. That's just showing the electromagnetic frequency of what it looks like just from regular AC lines. And the cell phone against your head. If it's a child, that cell phone signal's going right through their skull. It's just not as thick as adults. So yeah, most people that care about these things are going to even prefer just to use the Bluetooth headset rather than holding a cell phone up against your head these days. This is an image from one of our drawings. We do design services for people, and then we create a set of drawings which we use for our own construction, or sometimes we're just doing drawings for people that are doing DIY. So here's an example of what we'd write down on a set of plans where we just draw a dotted line around the bedroom area, and that's kind of a note there for electricians to keep wiring away from that area as much as possible. If the wiring is staying in that area, then what we do is we use, and it's common in the loft, then we'd use low voltage DC, so 12-volt DC lights. It's I'm not going to get into the whole AC DC thing, but AC is alternating current, and that alternating current is what produces most of the electromagnetic radiation, whereas DC is a direct current. Um, and so you don't get that same fluctuation and you don't get that same wave of magnetic frequencies flying off. And if you look at that loft space there, your bed's right there. If you've got 4 transformers from regular 120-volt lights that are transforming down to a 12-volt light, then you're going to pick up all of that EMF. So what we do is we put the transformer somewhere else, and then we just run our low voltage wiring up into the loft. So maybe we put it down under the sink in the kitchen and run it up through the wall. The other thing with lighting and connecting it to healthy homes is we're always going for a warm white. The cool white in the daylight are not very good for your circadian rhythms, and makes it harder to sleep at night, or maybe you're not getting the optimal night's sleep you can. But the other thing that we're looking for in our lights is a high CRI. If the light that you're looking at doesn't have a CRI, then it's probably because it's not worth mentioning. But the color rendering index is the percentage of color that you get on a regular spectrum of daylight in the day. So we've got sunrise to sunset, and there's 100% of spectrum of color there. And so a high CRI is going to be 90% or above is a nice healthy light to get. If you've got regular filament bulbs, then your CRI is just fine. It's just the DC LED lights that you're having to look for something, because it's being created electronically, basically, by those LEDs. Yeah, we try and get them dimmable. Some people are affected by the dimmers on these lights, but it's nice to have lights dimmable for sure. Okay, salvage materials. Yeah, I talked a little bit about this. I think people who are into salvaging know all this stuff. Windows and doors are hard. Well, the doors not so much, but windows, because tiny houses are so small, you need specific size windows. So it's a bit of a crapshoot. If you're going to be salvaging windows, then you should get them first before everything else. Flooring, cabinets, that's all pretty easy stuff. If you're wanting to get a bit more nerdy about material choices, the red list with the Living Building Challenge website, livingfuture.org, is the place to go as far as your chemical sheets on all building materials. And that's a pretty comprehensive list. It's also got a list of your materials that you should really try and avoid, as well as your best ones as well. And this Living Building Challenge is a really interesting system to sort of promote healthy building practices anyways. Okay, so we could do the Q&A, but I think it's going to be difficult just with how this is set up anyways. So I'm just going to jump back and see if I can share a screen about how we get the houses from built up off the foundation. So if you just give me a second here, I'll share the screen again. I'll share this one. Okay, this is a whatever 8x20 trailer. What we do specifically is we get the ribs of the trailer at the bottom. And we'll see some of the reasons for that now. I'm going to start off. The first thing that we do is we put in mouse wire. I know it's common to put in a metal pan. That's okay, but it's got no vapor permeability. So let's say you drop a huge whatever, let's say you've got a leaky water bottle and it's just been leaking all night. It's made its way through the floor and it hits your metal pan. That water is there. It's not going to go anywhere until the house is well. It's going to migrate to the lowest point, but maybe the lowest point is just randomly in the middle of that metal pan, and that water is not going anywhere. Accidents happen, and I'm just not really into the metal pan because I want moisture to be released whenever it finds its way into our cavity, and this being the floor cavity. So what we start off with is mouse wire. So that's rodent protection, basically. The next one we put, next layer is Mento or Tyvek or whatever house wrap you want, and we wrap it all the way around our metal frame. If we wrap it up like a present, then what we do is we put in our floor joists and we screw them to the frame horizontally. Sorry, vertically. If this makes sense. This means that we don't have to use full 2x8s and rip them down or whatever. 2x4 is fine. And the screws we're putting in a sort of a construction, like an engineering pattern, up, down. And we use, pardon me, we use galvanized fine thread self-tapping metal screws. Super strong. And our middle joists, we do have to cut down to match this height here. And you notice this thing here, which is super important to us, is that we've got a 1/2 inch gap so that our subfloor, which you'll see here, is not touching our trailer frame. Now that's creating an issue on the outside because we've just got floating plywood. So what we do is we put 1/2 inch pressure treated plywood strips all the way around our perimeter. And now we've got something for our 3/4 inch plywood subfloor to rest on. Once we get this stage ready, then I'm going to put some of our drainage in the floor. Services. There we go. Depending on the trailer size, sometimes I will put the water lines in the floor, and I'm going to keep them as high up as I can, like right up. I'll just notch that out right at the top. And these are actually going to be up higher. You have to mark them out, obviously, so that you don't put a nail through them later. But the rest of our drainage is going to run a positive drain to our lowest point. In this case, it's the toilet flange. And then our outlet's there, a nice 3-inch outlet. These drainage lines, they're usually going to be ABS, 2-inch, 1.5 inch, something like this. Way less chance of freezing because the water's just running through them as opposed to these PEX water lines where the water is sitting inside. I've used these a few times. These are called Hetvo. They're waterless P-traps. So it's getting into a bit of plumbing jargon here, but these can be installed in the floor because if you have a P-trap down here, like a regular P-trap, which is the plumbing thing that stops the gases from coming back up like this. The problem with these in the floor is they go quite low and there's water in this area here. And so that water can freeze. So this is one solution, but they don't last forever because it is just a valve in here. And so sometimes you may have to replace it, which is going to be painful. The other thing is if anything does happen down the line and a plumber doesn't know it's there and they throw their snake down, it'll destroy it. So that's, I guess, some caution there. It's not always the best solution. Next there, we've got insulation. Filling it up. Again, we're just using bats. Usually our trailer, all the trailers we're building are bigger now, so they're like a 2x8 inch frame. And it's a true 8 inches. So what we're usually using is a layer of 6-inch and a layer of 4-inch insulation, and it gets us right in there with that extra 1/2 inch. So we're maxing it out the insulation on our floor as much as we can because it's the coldest part of the tiny house. And then we've got a 3/4 inch plywood subfloor. And we're away to the races, as they say. We can build our wall systems, blah, blah, blah. So I think I made it to the end. If there's any questions in the chat here, I could hit them up. Do I feel it's significantly healthier EMF 10-foot wide trailer park model? As far as EMFs go, 10-foot wide park model versus a 8.5-inch foot wide. I don't know if it would be significantly less. That'd be a stretch, I think. Yeah. Are any of my healthy homes in New England to have a look at? I don't think so. Not in New England. Like I said, we're in Vancouver, Canada, and we have shipped across the country and like across Canada and also to Maine and where else? A couple of places out east for sure. But it seems like the cost of transport becomes a bit prohibitive. So most of ours are going down to Washington, Oregon. It seems like quite a few people that have health challenges are moving to New Mexico these days. Just the price of land's cheap and it's a nice dry climate. And then Colorado. So those are our main, and then of course British Columbia here in BC, our main areas. Is that it? Any more questions for anyone that's interested? Otherwise, I think Jay is up. And, appreciate everyone's time. Hopefully I got some information out there that's going to be useful. Yeah, I don't know what else to say there. You online there, Zach? Maybe not. Let's see. So my volume wasn't good. Hopefully that wasn't critical through the whole thing. Anyways. Let's see if any more questions come through. Oh, the one in Maine. Yeah, sure. The best way to contact me is by email, tinyhealthyhomes.com. And then I could contact that client and see if they're comfortable. It's funny with a lot of these tiny houses. I mean, if it's tiny house people, then they're comfortable, but some people are running the gauntlet of hiding under the radar of being busted by being parked somewhere that they're not supposed to be. So I can reach out to the client.
Hey, Ben.
Hey.
Love it. Great presentation. Sorry, I checked out the last few minutes because I was having to do some other work and just get things dialed in. But
I get it. You and Jason are busy.
Oh yeah, there's always a ton to be done, but it's always good. I love listening as much as I can. So
yeah, cool, man.
It's a pretty solid presentation. As always, you crushed it. You obviously know the healthy living, healthy building better than anybody. So super impactful. And I know there's quite a few people in here as well that are specifically looking and wanting to do, healthy, like low EMFs. And somebody the other day was talking about dirty electric and all that good stuff too. So yeah, I love that you can, present it really simply and quick and easy. So
awesome, man. Thanks so much for having me.
Oh yeah, for sure. Glad to have you on, and it's always a pleasure. And I'm excited to catch up again soon. So
totally. Thanks, man.
Yeah, for sure. All right. Well, appreciate it, and we'll talk to you later.
Thanks so much. See you later.
Yep. See you.